All right, get ready, because today we're going deep into some really cool, cutting-edge AI research.
Oh, yeah?
We're talking about how to make AI models, the ones that can write poems or even code,
Right.
way more efficient.
Ah,
Imagine AI that runs faster on smaller devices
wow.
and uses way less energy.
Yeah, that would be amazing.
That's what these transformer tricks we're looking at today could do.
It really is some exciting stuff.
So our deep dive today is all about a brand new paper by Niels Graef.
Yeah.
He's focused on skipless transformers.
Okay.
I'll be honest, I'm a little fuzzy on what that means.
Sure.
Could you explain it like you would to someone who's heard of AI but doesn't really get it?
Absolutely. You've probably heard of neural networks, right? Those
Yeah.
complex systems in AI that are kind of based on the human brain.
Mm-hmm.
A transformer is just a specific type of neural network that's become super popular, especially for dealing with language.
Right, like those chatbots that can have a conversation or
Exactly.
even write different creative text formats. So if you imagine a transformer as like a network
Right.
with all these interconnected layers,
Right.
each layer processes information and then passes it to the next one.
Right.
Traditional transformers have skipped connections, which are like shortcuts.
Yeah.
So information can jump ahead like express lanes on a highway.
That's a good way to put it.
But Graham's paper is all about skipless transformers, so no express lanes.
Right.
Why would you want to get rid of those shortcuts?
That's actually a really good question.
Yeah.
It seems kind of counterintuitive, but researchers are finding that removing those skip connections can actually make the model simpler.
Oh, interesting.
And sometimes it can actually improve how well it learns in certain situations.
So it's like decluttering your code
Right.
to make it run faster.
Exactly.
I like that analogy.
Yeah.
Okay, but before we get into the tricks themselves,
Sure.
can we take a step back? Why are researchers working so hard to make transformers more efficient?
Well, it's all about accessibility and sustainability. Right now, training and running those huge AI models takes a ton of computer power and energy.
Uh-huh.
It's really expensive
Mm-hmm.
and can have a big impact on the environment.
So if we could make them more efficient,
Yeah,
AI could be more accessible to like smaller companies or even individuals.
exactly.
That would be incredible.
It would be huge.
And we could reduce the carbon footprint of AI.
Yeah, that's a win for everyone.
Absolutely.
A win for sure.
Okay, so the stakes are high.
Definitely.
Let's get into Graef's paper, these transformer tricks.
Right?
What's the most mind-blowing idea he's proposing?
Well, one of the big ideas is this idea of merging layers within the transformer.
Merging layers.
Yeah, imagine taking a recipe,
Okay.
and instead of having all these separate steps, you combine some of the ingredients beforehand.
So you simplify things,
Right.
but the final dish is still the same.
Exactly.
So the dish is the AI model's output,
Uh-huh.
and the ingredients are different parts of the transformer.
You got it.
So by merging some layers, Graef reduces the total number of weights in the model, right?
That's right.
And weights are like the controls the model adjusts during training
Yeah, like the knobs and dials.
to learn from the data.
Exactly.
So fewer weights means less complexity, and that could mean a big boost in efficiency.
Yeah,
Wow, so slimming down the model can make it faster and greener?
it really can.
It's kind of counterintuitive.
It does, but think about it this way. Fewer weights mean there's less information to store and process,
Okay.
which leads to faster calculations,
Right.
less memory use,
Hmm.
and potentially even lower energy consumption.
That's pretty amazing.
It is.
But the real question is, does it actually work?
Right.
Are there real examples of where this has made a difference?
Absolutely. Graef tested his ideas using a couple of big language models, Pythia and Mistral, and the results are really impressive.
I bet you've got some juicy details for us.
I do.
Let's dive into those examples and see how much of a difference these transformer tricks can make.
Okay, let's do it.
So we've got these transformer tricks that could really shake things up.
Yeah.
Make AI models faster, smaller, use less energy.
Yeah.
But do they actually work?
That's the big question, right?
Yeah.
And Graef actually tested this stuff out.
Okay.
He looked at some large language models,
Uh-huh.
like Pythia and Mistral.
I think I've heard of those.
Yeah, they're pretty popular.
That get in the news?
Yeah, they're big and powerful models,
Yeah.
capable of some pretty amazing things.
But even they could use an efficiency boost.
Exactly. Even the best can get better.
So what happened when Graef applied these tricks? What did he see?
Okay, so get this. In Mistral 7B, he was able to remove just 15% of the weights.
Oh.
Remember, Those are like the model's parameters.
Right, the knobs and dials.
Yeah, and by doing that, he got a potential speed increase of 1.17x.
Whoa, wait a minute.
Pretty cool, right?
He made the model smaller, and it got faster.
It was kind of wild.
How does that even work?
It's all about the computational load. Fewer weights mean less data to crunch, which means less memory usage and faster calculations.
No, it's like...
It's like you're running a marathon with a heavy backpack,
Uh-huh.
and then you take some stuff out of the backpack.
And you can run faster.
Exactly. You're lighter and more efficient.
So it's like giving these AI models a performance upgrade,
Yeah, it's like tuning up the engine.
but without sacrificing any power?
Right, you get the same horsepower, but with better fuel efficiency.
And this could have a huge impact on energy consumption too, right?
Absolutely. Imagine data centers running these models using way less power.
That's a big deal.
Yeah, especially with climate change and all that.
For sure.
It's a game changer.
Okay, but let's get back to the merging thing.
Okay.
Can you explain how that actually works?
Sure. Grafe outlines a few different techniques, each with its own mathematical basis.
Sounds complicated.
It can be, but the basic idea is to combine certain operations within the transformer without changing the overall function.
So like simplifying a recipe, but still ending up with the same dish?
You got it.
And the dish is the AI model's output.
Right.
The ingredients are these mathematical operations.
Very nicely.
Now, remember those diagrams in the paper
Oh, yeah.
with the matrices and arrows?
Uh-huh.
Those are supposed to help us understand how this merging stuff works.
They do.
But to be honest, they kind of went over my head.
Yeah, they can be a little much.
Can we break them down without needing a PhD in math?
Of course. Let's look at one specific merging technique that shows how it works.
Okay.
Imagine you have 4 matrices called Q, K, V, and P.
All right.
They stand for query, key, value, and projection, which are key parts of the attention mechanism in a transformer.
Hold on. Attention. What's that?
Well, think about it like reading a book.
Okay.
You don't pay attention to every word equally, right?
Right.
You focus on the important parts, the ones that give you the meaning.
Uh-huh.
The attention mechanism in a transformer does something similar.
So it's like the model is learning to focus.
Exactly. It learns to weigh different parts of the input data based on how relevant they are to the task.
That's pretty neat.
It is. It's like the model is figuring out what to pay attention to.
Okay, I get that.
So where do those matrices fit in?
Yeah, what about those Q, K, V, and P things?
Well, those matrices are used to calculate those attention weights.
Okay.
The Q, K, and V matrices work together to figure out which parts of the input are most important.
Uh-huh.
And then the P matrix takes that information and projects it into a form that the next layer of the transformer can understand.
So it's like a relay race,
Yeah.
where each runner or matrix passes the baton to the next, but they're also deciding which runner gets the most support.
That's a great way to think about it.
So what Grafe does is he merges the Q, K, and V matrices with the P matrix, combining those steps into one,
Right.
like streamlining the relay race,
Yeah.
making it more efficient without changing the outcome.
You got it.
I'm starting to see how it all fits together. But I think it's time to bring this back to our listeners for a minute.
Yep.
You know, they might be wondering why this matters to them.
That's a good point. It's easy to get lost in the technical stuff,
Yeah,
but this research could really change how we use AI in our everyday lives.
exactly. We're talking about potential breakthroughs in so many areas.
Oh, yeah.
Like personalized education,
Yeah.
more accurate medical diagnoses.
All powered by AI models that are faster, more accessible, and more sustainable.
It's pretty amazing.
It really is.
This is just the beginning. There's so much more to explore.
Absolutely.
So stay tuned for part 3, where we'll dive into the future implications of all of this.
Yeah, we'll look at what it could mean for the world.
All right. Welcome back to the deep dive.
It's great to be back.
We've been talking all about transformer tricks
Right.
and how to make AI more efficient.
Ah.
It's really fascinating stuff.
It is.
So we've covered skipless transformers,
Yeah.
merging those matrices, the attention mechanism.
Right.
What does all of this point to for the future?
Well, one of the most exciting things is how this could change the way we design AI hardware.
Oh, interesting.
Right now, we're running these really complex models
Uh-huh.
on general-purpose hardware.
Right.
But what if we could build chips that were specifically made for these streamlined transformers?
So instead of trying to force something to fit,
Exactly.
we could design hardware that perfectly matches the software.
Yeah, it'd be like having a race car engine instead of a regular one.
You'd get way more speed and efficiency.
Exactly.
But what about the applications?
Right.
How could these transformer tricks change things in the real world?
Well, imagine a world where AI isn't limited to huge data centers.
Okay.
Think about running sophisticated AI models on your phone, or on a
Wow.
small sensor, or even a tiny device.
That would be incredible.
It would, wouldn't it?
We've all heard about AI assistants, but this would be something else.
Yeah, we could have truly intelligent devices all around us.
Interacting with the world.
It's a pretty amazing vision.
It is.
Imagine personalized tutors that change based on how you learn,
Wow.
or medical devices
Oh, yeah.
that can diagnose conditions using their own processing power.
That would be groundbreaking.
And we could have AI tools that help anyone be creative.
Yeah, write music, make art, design video games.
It's like giving everyone the power to create and innovate.
And all of this would be powered by AI that uses less energy
Right.
and has less impact on the environment.
It's not just about making AI more powerful, it's about making it sustainable.
And accessible to everyone.
Exactly.
So what are the biggest challenges and opportunities in this field?
Well, one challenge is making sure that these advances don't make AI less accurate.
Right, we don't want to sacrifice quality for efficiency.
Exactly. We need to find the right balance.
And what about opportunities?
I'm really excited about personalized AI.
Okay.
Imagine AI that adapts to your individual needs and preferences.
So it could understand you on a deeper level?
Yeah, it could understand your emotions, your goals.
Yeah, that could revolutionize so many things.
Couldn't it?
It's like having an AI companion that truly gets you.
It's a really exciting idea.
It is. But let's bring this back to our listeners again.
Sure.
This research could impact every single one of us.
Yeah, it's not just some abstract idea.
From the devices we use to the way we work, learn, and create.
AI is becoming more powerful and accessible all the time.
And these transformer tricks are paving the way for a future where AI is everywhere.
It's going to be a wild ride.
Well, I think we've covered a lot today.
We have.
We've explored some really complex concepts.
And we've seen a glimpse of what the future might hold.
It's been an amazing journey.
It has.
So if you want to learn more, Nils Grafe has made his code available.
He has.
And he even has a GitHub repository called Transformer Tricks.
You can check it out and learn all about these techniques.
So dive in, explore. Maybe you'll be the one to come up with the next breakthrough.
You never know.
A huge thank you to our expert for joining us today.
It was my pleasure.
And to all of our listeners, thank you for joining us on the Deep Dive.
Thanks for listening.
Keep exploring, keep learning, and keep diving deep.